Hello everyone, and thanks for tuning into a 12th Winter 2022-2023 update from GavsWeatherVids. So here we go again, it's time to bring you another winter update. We have reached update number 12, the 12th and penultimate update from GavsWeatherVids. Just got one more to do for you next week, followed by the week after, of course, with the winter forecast. So we are nearly at the end of our journey now, but we've still got a lot of data to show you this week and next. And this is going to be absolutely epic. It will probably be the most epic update that we've done so far. We've got so much to show you. I cannot wait to get started, and I will crack on with it for you in a moment. Just say that the first video today was our 6 a.m. upload. We've got another instalment of the Christmas countdown coming up for you later on this afternoon. Please like, share, subscribe on the videos. Thank you so much everybody for doing that. Thank you so much for sticking with this long journey of winter updates. We began this journey at the beginning of September, and you're stuck with it all the way through. I appreciate these long videos are not easy to digest. You know, they take a lot of concentration and a lot of time and effort. So thank you so much to each and every one of you for going on this journey with me. As I've still got quite a bit left to show. Thank you so much to Richard for the amazing winter updates gift. Thank you so much, my friend. Thank you so much to Richard, and thanks so much to Richard for the data within this video, the help that we've had in remote receiver swingometer from the King of Swing. So thank you so much to Richard. Thank you so much to Shryan as well, Shryan Brian, for the help on this epic 12th update. When we get to sections that they've helped with, of course, I will give them a shout out. So without further ado, I reckon we better get on because we've got so much to show. So let's just turn off the webcam. There we go, and we're going to show the swingometer first of all. So this is how the swingometer is looking in terms of where we're favouring a milder or a colder than average winter after 11 updates. This is up to the end of last week's 11th update. So here we go, let's count it down. 3, 2, 1... There we go! Wow, 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 wow! So we are now favouring a milder than average winter by 56%. There we see it, 56% chance of a mild winter. That is actually a swing from mild to cold on the week before. So the swingometer last week at the beginning of the 11th update showed a mild average winter being favoured by 60%. We just inched that back to 56%. So there we have it. After 11 updates up to the end of update number 11, we are favouring a mild average winter with our winter updates by 56%. You will find out at the beginning of next week's 13th update how the swingometer is looking, taking into account this 12th update. Will this 12th update move the swingometer, or will it stay there? Or, you know, you'll find out at the beginning of next week's 12th update. But as of the end of the 11th update, favouring a mild average winter by 56%, but we have had a 4% swing there from mild to cold. Thank you so much to our King of Swing, Richard Shaw, for the swingometer. Thank you so much, Rich. Right, let's crack on then. So we're going to begin with oceans data for this one. So we've got our 4 areas of interest, of course. We've got the ENSO region just here. We've got the northern and northeastern Pacific over here. We've got the Indian Ocean over there. And we've got the Atlantic Ocean over here. That's how the ocean's looking when we did last week's 11th update. This is the latest. So let's deal with the ENSO region first of all. We are seeing a further cooling in the eastern portion of the equatorial Pacific Ocean. All regions of the ENSO region, all regions of the equatorial Pacific Ocean are showing a cold event, are showing La Nina, but you can see it is clearly coldest over in the eastern portion of the equatorial Pacific Ocean. We explained last week, but this is going to be an eastern-based La Nina. So what we explained within reanalysis, within our analogues, that does sometimes favour colder than average winter. I think that's why the swingometer, one of the reasons why the swingometer moved a little bit from mild to cold. And we see further evidence there of this eastern-based La Nina that we've got going. It's going to be a La Nina winter, definitely. It will be an eastern-based La Nina, and we can see that over past week we have had further cooling in the eastern portion of the equatorial Pacific Ocean. Going further north into the northern Pacific, again, that's how it was looking last week. We're monitoring this cooling going on around here. That's how it was looking last week. This is the latest. So the cooling is still there. Possibly eased off slightly over past week, eased off, but it has clearly cooled down in that northeastern corner of the equatorial Pacific Ocean, of the North Pacific Ocean, I should say. And I would expect that cooling to continue, you know, with this cooling going on in the eastern portion of the equatorial Pacific Ocean. I expect cooling to continue in the northeastern Pacific as well. Over in the Indian Ocean, again, that's how we looked last week. This is how we look this week. Very little change there. We are losing the negative IOD, Indian Ocean Dipole signature, that we have through the last part of the summer and into the autumn. We are reverting back to a neutral IOD type state. And then over in the North Atlantic, this is where we're looking now, of course. Now let's go back to last week. That's how the North Atlantic looked last week. This is the latest. Not much change there. No, it's still pretty warm through here and into the Norwegian Sea as well. Interestingly, it's cooled a little bit through there. Quite warm through here. Yeah, just generally still looking pretty warm with the sea surface temperature anomalies across much of the North Atlantic, to be honest. This is the 7-day change, so this is how the sea surface temperatures have changed in the past 7 days. So warming through here, that's as we're going from where it was cold there earlier on in the autumn, with negative IOD. We're warming things up, we're reverting to a neutral IOD through there. Has warmed a little bit in this far northeastern corner of the Pacific Ocean up here. It's only a 7-day change, so I won't be overly worried about that. I expect it'll start cooling down next week. You can see that the eastern portion of the ENSO region here in the equatorial Pacific Ocean has turned colder over the past 7 days. It has warmed a bit in the central and western part of the Pacific Ocean, although still, you know, cold on average. And then in the North Atlantic, it's generally cooled a little bit in most areas, actually. Most areas of the North Atlantic have cooled a little bit over the past 7 days, but of course the anomaly is so warm it's not enough to drag the anomalies below average. But most parts of the Atlantic have cooled a little bit. Has warmed though in the Norwegian Sea, and it's still warming here in the Caribbean and whatnot. Right, so if you have a look at CFSV2, that's forecasting that weak La Nina condition will continue. Got our temperature anomalies along the side, dates in monthly periods along the bottom. We're around here at the moment, so around 1 degree below average in the central part of the equatorial Pacific Ocean, and that's where these events are designated from, be they El Nino or La Nina. It's region 3.4, central part of the Pacific Ocean. So technically, in theory, this will be a weak La Nina event. However, if we go to regions 1 and 2, which is the eastern portion, you can see that there it is colder. We're around 1.5 degrees below average, which is moderate La Nina level, and that's going to carry on to around January, gradually lifting back up to around 1 degree, and then into the new year we find that warming up. Actually, by the time we get into the early summer, long way out of course, we might be having a little bit of an El Nino type signature appearing there in the eastern part of the equatorial Pacific Ocean. So again, that tells us it's colder in the east and going to be for the next month or two, but it is in the central part of the equatorial Pacific Ocean, which again just confirms this will be an eastern-based La Nina. Southern Oscillation Index is looking like this. So the SOI measuring air pressure between Darwin and Tahiti. We've got a positive SOI. It tells us about the atmospheric setup is reflective of La Nina. We've got a negative SOI. The atmospheric setup is reflective of El Nino. This is from Queensland government, I think. If we come down here, these are our columns. So date column just there, column for Tahiti there, Darwin there, and the overall SOI number just there. Positivity of the SOI continues. We go a little bit negative there on the 13th, down to -7. But come back up, 15th November at 15, 18th of November at plus 11, 19th of November at plus 9. The absolute setup is very much in a La Nina state, as you'd expect with such a strong signal in the ocean. So we continue with this La Nina certainly until the end of the year, probably into the open of next year, and then it will revert back to ENSO neutral by the spring. The 30-day average, which is this red line, it has come down from where it was back in October when it's up there. It's come down to here, but still solidly positive. That's plus 8, and I'd expect that'll probably rise a little bit again before the end of the year. Richard noticed this when we did last week's ENSO special. This is the cold and warm episode by season page from CPC, NCB and NOAA. So Richard noted that we have got a similarity. This is showing ENSO events by tri-monthly periods, right way back to 1950. So the current year, of course, is 2022 down here, and you see the whole year has actually been a La Nina year, interestingly, and this is like the triple dip La Nina, as I explained last week. Richard noted that we have got a similarity with the La Nina event of 2008 and 2009, just here. Also got a similarity with the La Nina event of 2011 and 2010-2011, which of course contained the December to remember, and 2017-2018, which again, all three of those winters have considerable levels of cold weather and contain snow at times. So you know, we thought that was worth throwing in to the mix, just that there is a bit of similarity between the current scenario, the current La Nina, and those three that did contain relatively cold conditions. Not necessarily cold winters from beginning to end, but cold, you know, they contain cold weather at least at some point in part during those winters, and some quite significant snow. So thanks so much to Rich for pointing that out. We have established in past years, but weak La Nina will tend to increase the possibility of like colder winter weather, and so I suspect that's what's going on there, particularly if it again is eastern days. Thank you so much, Rich. Right, 2022 Atlantic hurricane season. So this is how the scores on the doors are currently looking. Miss Ford from the Wikipedia page. So the season so far had 16 tropical depressions, 14 tropical storms, 8 hurricanes, and 2 major Category 3 or above hurricanes. I think that is unchanged on last week, and I don't think that's going to change. I think the season has ended. I think we'll have a shutdown of the tropical Atlantic. So I think that is where the situation will stay. This is how ACE is currently looking. So this is updated by our ACE master Shryan Brewing. Thank you so much, Shryan, for updating our ACE. ACE is a way of showing how much energy all of these storms are emitting, both individually and also on a season by season basis. The overall season is classified as below normal, near normal, above average. Hyperactive, we go back to 1851 with this, but it's going to come down to the most recent year. So currently for 2022, just here, our ACE is sitting at 95.10, 95.10. That is after 14 tropical storms, 8 hurricanes and 2 major hurricanes, and that means that the season has been near normal, although a little bit on the low side, because you would expect by this point, 19th of November, in a hurricane season, to have an ACE of around 120.20. So we're a little bit on the low side, even though we're near normal. And that will be after 14 storms, 7 hurricanes. Actually have 1 more hurricane than you would expect, and 3 major Category 3 or above hurricanes. So we're lacking that last major hurricane to lift the ACE up to that 120.20. Now we're going to look at, thank you so much, Shryan, our ACE master, for keeping us updated with the ACE. Right, so we're going to look at hurricanes data for our analogues. We've got 2 sets show. I'll bring you the first set right now, and this is going to be looking at ACE. So we're looking at winters following hurricane seasons with an ACE accumulated cyclone energy of 80 to 110. So average, but on the lower side of average. And that, of course, is going to place the current season, 2022, slap bang in the middle of that range, as we've already established. Our ACE for this season is 95.10. Right, so the first winter following a hurricane season with an ACE of 80 to 110 is 1953-1954. So winter of 1954 turns cold at the end, with above average heights to the north and winds coming in from the east, low pressure down here to the south. It has a mild December, and it gets colder later on in winter, particularly cold and wintry in February. Our next season, winter following a hurricane season with an ACE of 80 to 110, is 1954-1955. This is a genuinely cold winter with blocking around Greenland and low pressure to our south and east. So winds are coming in from an east or a northeasterly direction. A cold and wintry January and February in 1955. Next up we have 1958-1959. So this one with low pressure out in the Atlantic, high pressure up here. This has a very cold January and then gets much milder for February. We've got 1971-1972. This is a relatively mild winter, although it does have a Scandinavian high, but overall that's a pretty mild winter, just one proper cold spell, I think, in that winter. Otherwise, it's relatively mild. The next winter, following a hurricane season with an ACE of 80 to 110, is 1976-1977. Brutal cold winter in eastern parts of America, with this trough of low pressure just here combined with Greenland blocking. For us, it starts cold December and to some degree January. Quite cold, and then it gets milder later on in the winter, but it's remembered as being a very severely cold winter in northern and eastern parts of America. The next hurricane season is 1979-90, and the winter is 1979-1980. So this one with low pressure in off the Atlantic. There's a little bit of blocking up to the north, but that's a relatively mildish winter, although it does have some cold snaps. We've got 1981-1982 up next, following ACE with ACE of 80 to 110, and this one is a cold winter, especially so in December. Freezing cold December, low pressure down here, blocking up there. It's a freezing cold December, and there's big freeze up in January 1982 as well, before turns milder in February. We've got 84-85 following a hurricane season with an ACE of 80 to 110. This is another cold winter. This is a really cold winter with high pressure around Svalbard and low pressure to our south. Winds are in from an easterly direction. In that wind has a very cold January. December is relatively mild, and then the cold is on up to February. Another cold winter for 85-86. Look at this one with high pressure around Greenland, low pressure to our south. Winds in from an easterly direction. It has a severely cold February. It's relatively mild in December, or very mild in December, and then it gets cold right at the end of December during Christmas week. Cold on off through January of 86, and then severely freezing cold in February. Our last sub-zero CET February was in 1986. 1990-1991 is another cold winter. This one with high pressure centred towards Scandinavia. Winds in the east. That has a severely cold spell in February. Famous freeze up. We've got, so we're out sync there, I think, got 1988, 1989. So this is a milder winter with low pressure to the north, high pressure to the south, winds in from westerly direction. So that's a very mild winter for 88, 89, relatively dry too. Then we've got 1990, 1991. We've got 2001, 2002 showing up. So this one with high pressure south, low pressure to the north. However, the months are very different individually, so that analog doesn't tell you all that much. So December of 2001 is quite a chilly month, has a cold Christmas to New Year. January 2002, very dry, starts off really cold, then gets milder, and then February 2002 is mild and wet. Right, that's the last year. So this is how all Decembers combined are looking following hurricane hurricane seasons with an ACE of 80 to 110, around average, but a bit below, you know, on the low side of average. So overall, it looks like an unsettled signal for these Decembers, with low pressure to the south and east. There is some higher pressure up here, but probably not strong enough to do all that much cold, so a relatively mild signal for the Decembers. All January's combined, though, look like that. Much more interesting blocking appearing around Greenland and Iceland. Low pressure getting pushed southwards, winds coming in more from an easterly direction. You could envisage a cold January possible with that. And all February's combined, following ACE with hurricane season with ACE of 80 to 110. Looks like that. High pressure was Scandinavia, low pressure down here. You would assume we could be bringing wind from the east with both February's, probably a battleground month with both February's probably, and all winters combined, following a hurricane seasons with an ACE of 80 to 110. Looks like that. Quite an unsettled signal, but there is like blocking to the north and winds in from the east. I think overall those years are probably favouring a colder winter outcome, to be honest. We've got more to show you for our analogues at the end of the video for, you know, hurricane season analogues and whatnot. And as I say, that will be coming up at the end of the video. I'm going to have a little pause, I think, there. You go off and stretch your legs, digest what you just witnessed, and we'll be back with more data in a mo. So see you in 2 seconds. Okay, we're back and we're ready to resume. Wow, wow, wow. Ready to resume the epic 12th Winter 2022-2023 update from GavsWeatherVids. Thank you so much, everyone, for watching so far. Please like, share, subscribe, and thank you so much. Thank you so much to Shrine for getting all of those analog years together for us that we showed you just before we have this little pause. Thank you so much to Shrine and to Richard for the data in that first section. Right, we're going to do solar data now. So here we go. This is how the solar disk is looking on our side of the disk today from Surham.net. We've got various sunspot regions, and solar activity is actually at moderate levels, I do believe, and is expected to stay at moderate levels for the next 3 days. This is the GavsWeatherVids Winter Updates Solar Activity Tracker, updated by Shrine. So the orange line and orange spot depicting each individual day's worth of sunspot activity. So the latest days are around here. You see, actually, we're hovering at like a lower level of activity in terms of total sunspot numbers at the moment. We had our last sort of big spike up there back at the end of September. Since then, we've been at this sort of lower level of sunspot numbers, and that's where we are just about. It has been enough to dip down both the 7-day average and the 30-day average. 7-day average, of course, is this orange line that's dropped a little bit. And the green line as well, which is the 30-day average, which, of course, doesn't move quite as much because it is a 30-day average. That's sort of hovering at this lower level as well after dropping from where it was back at the end of September and into the beginning of October. We are, you know, seeing a moderate level of, modest level of sunspot activity, but we're a little bit lower than where we was earlier on in the autumn. Thank you so much to Shrine for that. Now, who am I today? Let's have a look, let's have a look, let's have a look, let's have a look. Oh, it's Gav4. I've been turned into, I think that's Chris Hemsworth, isn't it? I don't know. I'm not as good looking as him, I can tell you that. Mrs. P was saying your dreams, Gavin. Thank you, Rich, for turning me into 4. Into Mr. Hemsworth. I don't know. I pull it off not too bad though, really, the look, don't I? I don't know. Right, okay, so this is showing spotless days and the current spotless stretch. So, we have had 1 day this year without sunspots, which is less than 1% of the year. And the current spotless stretch is 0 days, considering, as we've already established, you know, but we have had sunspots every day for several weeks and months. For 2021, so for 2021 we had 64 days without sunspot. sunspots. That was 18% of the year. For 2020, we had 208 days without sunspots. That was 67% of the year. And for 2019, we had 281 days without sunspots, which was 77% of the year. That was our solar minimum year, of course. The comparable year to the last solar cycle number 24, is 2011. That had 2 days without sunspots, which again was less than 1% of the year. The following year, 2012, had all days with sunspots, had no days without sunspots. So we're expecting that 2023 will have every single day with at least one sunspot. Thank you so much, Richard and Shryan, for the data. Thank you so much, Rich, for turning me into 4. Right, QBO next. Whilst I've been on our station, just to again clarify that we are in a westerly QBO. It's from NASA. That's the top of stratosphere 10 HPA. That's the troposphere 30 to 50 HPA. And just to confirm that we are in the westerly phase of the quasi-biennial oscillation, the westerly QBO has descended from the stratosphere into the troposphere. The westerly QBO continues. Arctic oscillation observed and forecast is looking like this. So the AO just need that start measuring air pressures over the Arctic and the North Pole. When it's positive, got low pressure. When it's negative, got high pressure blocking over the pole. Been generally positive with the AO since October and into November. We're still positive at the moment. GFS ensembles, though, are forecast that towards the end of November, the AO will go negative before bouncing back up to neutral at the beginning of December. Looks like there could be a little bit of change going on over the Arctic and over the North Pole with more of a blocking signature. The NAO is looking like this at the moment. The NAO is weakly positive, very close to neutral. GFS ensembles are forecasting that the NAO will actually go negative as we come to the last stages of November. So with both the indexes, the AO and the NAO going negative, could that be a signal for something a little bit colder maybe in the last week or so of November? I wonder, but it certainly looks like there's a bit of a change going on to the established pattern so far this autumn. Stratospheric data next is how temperatures are currently looking at 10 HPA against average from the JMA. So the grey line is the average line, the black line is where the temperature has been and where the temperature currently is at 10 HPA in the stratosphere over North Pole. You see that we're cold average now at the moment. We're underneath that grey line, so temperatures have gone somewhere around minus 75 at 10 HPA in the stratosphere, which is a bit colder than expect it to be at this time of the year. And at 30 HPA, we also see that temperature is now colder than average underneath the grey line. And this is going to fuel the polar vortex. So this is going to fuel the zone of wind, and the zone of wind then will power the polar vortex. So this is a signal, well, it's a little bit contrasting, conflicted to the AO signal, which suggests a bit of blocking. The colder than average temperature would suggest that we're going to see the polar vortex powering up a little bit via the zone of wind. So the cold temperatures are like the petrol, and the zone of wind is like the engine, and you know the polar vortex itself is like the car being driven by the engine. Now these are how the temperatures are currently looking at 10 HPA with the GFS bar. You see the temperature over the Arctic and North Pole is blue purple because these are the cold temperatures. 10 HPA, you see around mid minus 70s there over the top of the North Pole. This is how things are forecasted about. So staying pretty cold out to like a week away. The coldest of the temperatures possibly pushing more towards Canada and Greenland and whatnot, though. A bit of a warming going on over the Siberian side of the Arctic with these yellow and green colours, although not enough to dent the polar vortex up to that point. In the extended range, this is how things continue to look. So again, just hovering around mid-minus 70s really over the top of the pole. The coldest temperatures around minus 80, push more towards the North Atlantic and Greenland and northern parts of Europe and whatnot. But I think it suggests that, like, for the next couple of weeks, we're going to see a pretty strong polar vortex. There's no suggestion there of any notable warming of the stratosphere up to the beginning of December. That gets to the 5th of December. There's no sign of any notable warming of the stratosphere up to that point. Looks like it's going to stay around average or a bit colder than normal. Now I've got some forecasts to show you. So this is how the latest this from Copernicus.eu. This is how the latest ECMWF season model forecasting zonal winds. So remember, zonal winds will be powering the polar vortex. If the zonal winds is stronger, stronger than average, and you'll have a stronger than average polar vortex normally. So now we've been showing you these two winter updates. Apparently, I've been reading this wrong. So I've been focusing on the black line there, which is daily climatology. And apparently, you're supposed to ignore that, and you're supposed to compare the blue line, which is the forecast ensemble mean, to the orange line, which is the model climate mean. If the forecast ensemble mean is above the model climate mean, then I hope you're following this. It's very complicated. They've come up with just about the most complicated way of showing this data. But if the blue line, the forecast ensemble mean, is above the model climate mean, it shows that the model is forecasting stronger than average zonal wind. It's the same if the blue line is underneath that orange line. So the ECMW, that season model, is actually forecasting quite a strong zonal wind through this winter. Yeah, you know, the blue line is generally slightly above that orange line. So it looks like the ECMWF season model forecasting zonal winds to be pretty strong through this winter. We've got Meteo France, where we also see that the blue line is above the orange line just there. So again, stronger than average, strong zonal wind being forecast by Meteo France. Bit different for DWD. The DWD German model forecasting a weaker zonal wind, especially through December. Then crossover with the orange line occurs into January, and then into the last part of winter, DWD sends the zonal wind stronger than average quite substantially. So some of our ensemble members there are going for a reversal of zonal winds in December, but DWD, I think, is like flirting with a bit of a southern stratospheric warming potentially in December, probably more towards the Christmas period, and then strengthens the zonal wind in the latter part of the winter. UK Met, looks like that's going for sort of average zonal wind type conditions, really, although both the orange and blue lines are underneath the black line, which I think is worth noting, which that's like climatology. But I've been told that I'm supposed to ignore the black line, really. So I think basically with the UK Met, like average zonal wind conditions. And then lastly, JMA. Again, that looks much of a muchness, although the blue line is slightly under the orange line there from December into January. So that might be going for a little bit of a weaker zonal wind. There are several ensemble blue members from the JMA model that are going for a reversal of zonal winds there. So it's a mixed bag, and forecasting like stratospheric polar vortex, zonal winds. It is experimental, really. It's something that's in its infancy. They haven't been doing it all that long with these models, so you'd expect like contrasts and conflicting signals, and that's what we see there, with a couple of the models going for a stronger zonal wind, and particularly with DWD going for a weaker zonal wind. Right, we'll have a little stoppage again. When we come back, we're going to look at Eurasian snow cover. Interesting developments there. I shall see you in 2 seconds for that. See you very soon. Okay, we're back and we're ready to resume the epic 12th Winter 2022-2023 update. If you enjoyed the video so far, please like, share, subscribe. Thank you so much, everybody, for doing that. Eurasian snow cover data coming up next. Thank you so much, Richard, for the incredible gift there. Thank you so much, Rich. Right, so this is how Eurasian snow cover was looking when we did last week's 11th update. So we have got the snow line then from Scandinavia in towards the west of Russia. That's how snow cover was looking last week. This is the latest. Wow. We've had a big expansion of snow cover all the way into eastern and even into central Europe, got into eastern parts of Poland. So much of Scandinavia is now covered with snow. all of Western Russia really covered with snow, and we have now pushed that snow line into certainly the eastern part of Europe, if not central part of Europe. Right, so how does that compare with previous years at this point, as of the 18th of November? Let's have a look. So we are way ahead of 2021 at this point in the year. We are way ahead of 2020 at this point of the year. Look at that. We are way ahead of 2019 for Russian European snow cover, although probably quite close to Scandinavian snow cover. We are way ahead of 2017. Wow. We haven't got 2018. I don't know what's happened to that. We are way ahead of 2016 for, actually, probably not way ahead of 2016. A little bit ahead. I mean, I got into Eastern Europe, but not as far in. So we're a little bit ahead of 2016 now. 2015, we're ahead of 2015 for both Russian and also Scandinavian and European snow cover. We are well ahead of 2014 as well. Look at that, absolutely no comparison. We're well ahead of 2013, goodness gracious me. We are well ahead of 2012 as well, well ahead of 2012. 2011, we are ahead of 2011, especially so for Scandinavian snow cover, but also for European snow cover. Look at that, well ahead of 2010 for Russian and European snow cover, although we're a little bit behind for Scandinavian snow cover. Right, okay, I've accidentally got rid of the wrong chart. I've got to get that back up to do comparison. Hold on, everyone. Okay, we're back. So we can start comparing again. Right, so that's 2010, and we are well ahead of 2010 for European snow cover. That's 2009. We are ahead of 2009 as well. We have very few years that we've got snow line that far into Europe at this point in November. We are ahead of 2008 as well for Scandinavian and also for Russian European snow cover. That's 2007. So that's one of the years that we're behind, actually. We're a little bit behind 2007. That's a mild winter, of course, 2007, 2008. We're ahead of 2006. That's 2005. We are way ahead of 2005. 2004. We are also way ahead of that year. That's 2003, which we are way ahead of too. That is 2002. Where are we? 2002. No, that's 2003. Drat. Right, okay, that's 2001. We're well ahead of 2001. That's 2000. We are way ahead of 2000 as well. That is 1999. We're ahead of that year too, and that is 1998. We're probably very close, actually, to 1998. Out of all of the years, I think that's the one that we are very close to. Right, we're going further back than that, however. So we're going to go back to the 1960s now with this. So let's do that. So we're not going to compare now. Just keep an eye on where the snow line is. That's where the snow line's got to. Really from like Scandinavia into eastern parts of Europe. Keep that in your mind and sort of turn your head round and we'll do this for you. So 1997, we are ahead of 1997 for certainly Russian and European snow cover. We're ahead of 1996 for Russian and European snow cover. Probably a little bit behind 1995. We have got some snow even into France at this point in 1995. So we're behind that year. One of the few years we are actually behind. 1994, we are ahead of 1994, certainly for Russian European snow cover. We're ahead of 1993 as well for Scandinavian snow cover, probably quite close for Russian European snow cover. 1992, we are probably quite close to, maybe a little bit ahead of. 1991, I think with that year, we are probably quite close to that, maybe a little bit behind it. 1990, we're ahead of that year. We're well ahead of 1989 as well. 1988, I think we're a little bit ahead of 1988. 1987, ahead of that year, certainly for Scandinavian snow cover. We're ahead of 1986, we're ahead of 1985, we're ahead of 1984, we're ahead of 1983, ahead of 1982, we're ahead of 1981, certainly for Russian and European snow cover, I think. For 1980, probably a little bit ahead of that year too, ahead of 1979, we're ahead of 1978 as well. That's followed by a very cold winter. 1977, I think we're a little bit ahead of that year. 1976, we're ahead of that year too. We're ahead of 1975, ahead of 1974, ahead of 1973. Probably quite close to 1972. Let me know which years you think we're closest to in the comments, everyone. 1971, probably a little bit ahead of that one. 1970. You know, it's much of a muchness with some of these years. Some of these years we are close to. 1968, I think we're probably quite close to that year. 1967, we're ahead of that year, and we're ahead of 1966. We're doing good for snow cover right now. There aren't that many years that get the snow line that far into Europe, by this point in November. So we've done well there. We've done well in the past week. Major gains. Right, we're going to start the video one last time. When we come back, we're going to end this Epic 12 update having a look at the second batch of analogues. So I shall see you in 2 seconds for that. See you in a mo. Right, final part of the Epic 12 Winter 2022-2023 update from GavsWeatherVids. If you enjoyed the video so far, I hope you have. Please can you like, share and subscribe. Thank you so much, everybody, for doing that for us. Thank you so much. Thank you so much, Rich, for the gift. And let's just bring you the final section of this epic 12th update. So we had a late hurricane on the 4th of November. National Hurricane Center began monitoring the northeastern Caribbean Sea and southwestern Atlantic, where a large non-tropical low pressure system was expected to develop within a few days. That eventually developed into Hurricane Nicole, and so we had a November hurricane, which doesn't happen all that regularly, actually, but has got more common in recent years. And Richard, our lovely friend Richard Shaw, suggested that we might want to look at winters following hurricane seasons that have November hurricanes, and so that's what we're going to do for this last set of analogues. And the first year, wow, it's Badaddy! Wow, this is for Daddy of Cold Winters. It's 62, 63. Yes, the Daddy of Cold Winters actually followed a hurricane season. It's a very quiet hurricane season as well in 1962, but it followed a hurricane season that had a November hurricane. And so this is it, everyone. This is the analogue for the Daddy of Cold Winters, with blocking around Iceland and Greenland, low pressure projection pushed southwards into southern parts of Europe, and winds, of course, all the time in from the east. A severely cold winter, the coldest winter since 1740, and it did follow wow, a November hurricane. Right, okay, we've also got 1969, 1970. This is a pretty cold winter as well at the end of 1960s, with high pressure in the North Atlantic towards Greenland, low pressure to our east and south. This one gets cold later, turns very cold later on in the winter. We've got 1980, 1981. Thank you so much, Schreier, for getting these years together for us, by the way. Thank you so much, Schreier, sorting out the years for us. We've got 1980, 1981. Mildish winter, does have quite a cold January, though, I think, in 81. We've got 84, 85. It's back. It was there in the earlier set. It's back again with above average heights to the north and winds in from the east. That's a very cold winter. Has a very cold January. We've got 1985, 1986. That is back as well. High pressure around Greenland, low pressure to our south. That has a severely cold, and I do mean severely cold, February. We've got 86, 87. So I've got the hat trick there. I've got the trilogy of the mid-1980s cold winters, the three of them, 84, 85, 85, 86, 86, 87. This is the last one following a November hurricane in November. This one, again, quite a cold winter, especially so in January, where we get severely cold weather. Winds are in from the east and from the northeast. Bit of a gap then to 94, 95, with high pressure to the south, low pressure to the north. This is a mild winter, mild and wet for 94, 95. We've got 96, 97. So that has a cold December and cold Christmas, and then it gets very mild and wet for February. Does have quite a severely cold spell though around Christmas and New Year, 96, 97. Got 98, 99, which is just a generally mild winter though. Does contain some cold snaps, winds coming in from off the Atlantic. We've got 1999, 2000, another mild winter, low pressure to the north, high pressure to the south, winds in from the west. We have got 2001, 2002, that's back as well with high pressure down there, low pressure there, as we explained. The first set of analogues, that doesn't tell you everything you need to know about that winter though. We've got 2005, 2006, which we've been seeing quite a lot of this season, and that's the failed cold winter. It looks like it should be a very cold winter with lots of blocking to the north and northeast, but wasn't particularly. We've got 2008, 2009, the first of a run of cold winters from 08, 09, 12, 13, low pressure to south, high pressure to north, winds in from the east. That has a very cold spell in the first half of February. Got 2009, 2010, severely cold winter. This one with blocking around Greenland, low pressure to our south, winds in from the east. That's a very cold winter for 09-10. Milder winter for 2015-16, very significantly so. Has the mildest December on record, very strong El Nino going on with that winter though. Of course, we've got 2016, 2017, which is a dry, anticyclonic, very boring type winter. We've got 2020, 2021, the teaser winter. Teaser. With blocking within high latitudes and low pressure to the south, winds in from the east for Scotland. It's almost a very cold winter, that one. Just doesn't quite, just doesn't quite come up. But it is very close to it. So this is how all December's combined are looking following November hurricanes. And it looks like that. High pressure out to the west, some blocking to the north. You can certainly envisage cold snap potential with a lot of those Decembers. This is how all January's combined are looking following November hurricanes. Mid-Atlantic ridge towards Greenland, Iceland, low pressure to the south and east, winds in from a cold easterly direction. That looks like it favours a cold January, doesn't it? All February's combined, also looking very interesting, significant amount blocking around Greenland, low pressure to our south and east, winds again in from an easterly direction. A cold February could be favoured there. And all winters combined following November hurricanes with blocking around Greenland, low pressure to our south and east, winds in from an east or northeasterly direction a lot of the time. If we put two sets of analogues together, these are our overlap years, 84, 85, 85, 86, and 2000, 2001, 2002. So this is how all Decembers combined are looking, following the two sets of overlap years, two sets of analogues with the overlap years. Anticyclonic for the Decembers, probably not overly cold, but January favours a cold outcome with high pressure around Greenland, Iceland, low pressure to our south and east, winds in from the east. We've got 85 in with that, and then all February's again favouring cold outcome. We've got 1986 in with that, high pressure around Greenland, Iceland, low pressure south and east, winds in from an easterly direction. And then finally all winters combined with the overlap years. Look at that, favours a cold outcome with high pressure around Greenland, Iceland, low pressure to our south. Keep in mind 2001, 2002 eventually turned into a very mild winter. And we're done. Thank you so much, everybody, for sticking with this epic 12th update. We're just under 50 minutes. Wow, wow, wow. I didn't think I'd be able to do it, but we're still just under 50 minutes. Thank you so much, everybody. It's been amazing. It's been incredible. Thank you so much for sticking with this 12th update. Thank you so much to Schreier, and thank you so much to Richard for all of the help on this update. Amazing, incredible, and that, ladies and gentlemen, is your penultimate winter update. Got one more winter update to show you next week, the 13th and final winter update. Is going to be a real epic. Going to try and show you some November data with that. So, last winter update before the winter forecast the following week, next Sunday. We'll be discussing this 12th winter update in the live stream tomorrow. That will be coming up at 8 p.m. on the channel. I'm sure I have lots of questions, so we'll be discussing winter update then. You enjoy the rest of your Sunday, and for this epic 12th winter update, that's all for now. And thank you so much for watching. Bye for now.